Okay, so in this video we are going to see about how to find out the RMS current of half wave rectifier. Okay, so IRMS means RMS current. So this is the IRMS formula 1 by 2 pi 0 to 2 pi, and this is the input signal. Okay, so RMS means what? Root means square, right? So square root, and you have to take the square of the input signal. So 1 by 2 pi 0 to 2 pi means one full sine wave uடைய cycle. So one full sine wave cycle is 2 pi, right? 0 pi 2 pi. So 0 to 2 pi, and this is the input signal. So you have to take the square. So I square m sine square omega t into d of omega t. Okay, so now you can split up this 0 to 2 pi wave into a positive half and negative half. Okay, so now this is a full wave. So 0 to pi is the positive half of the cycle, and pi to 2 pi is the negative half of the wave, right? So this 0 to 2 pi, you can write it as 0 to pi plus pi to 2 pi. Okay, so now see here 1 by 2 pi. So 0 to pi means what? So in the half wave rectifier, what is the function of the half wave rectifier? So during the positive half of the cycle, you will get the output. So you will get the output only during the positive half of the cycle, and during negative half of the cycle, you will not get any wave. Okay, so during the positive half of the cycle you will get the output, and during the negative half of the cycle you will not get any output. This is the function of the half wave rectifier. So 0 to pi you will get the output, and during pi to 2 pi you will not get any wave, right? So here just you compare this waveform with this equation. So during 0 to pi you will get the wave, you will get the signal, and from pi to 2 pi you will not get any wave. So you have to put the 0 value from pi to 2 pi. So this whole terms become a 0, right? So now you have to take only this term. So square root of 1 by 2 pi 0 to pi im square sine square omega t d omega t. Okay, so now you take out this im square outside. So im square divided by 2 pi 0 to pi sine square omega t d omega t. Okay, now you can write, so you all know that, right? So sine square theta is equal to 1 minus cos 2 theta divided by 2. This is the formula of sine square theta. So here theta is nothing but omega t, right? So you can write this sine square omega t as 1 minus cos 2 omega t divided by 2 into d of omega t. Okay, into d of omega t. So im square divided by, now you can take out this 2 outside. So im square divided by 4 pi into 1 d of omega t minus, so in this term also you are having 2, right? So this 2 is common for both 1 and cos 2 omega t. So you can write this term like this also, 1 by 2 minus cos 2 omega t divided by 2, right? So from this 1 by 2 you are taking the 2 outside. So 1 into d omega of t, and from this term you will take the 1 by 2 outside and cos 2 omega t into d of omega t. Okay, now you can differentiate this. See, im square by 4 pi. So one differentiate, if you differentiate this term means what you will get? Omega t 0 to pi minus 1 by t. So cos 2 theta means sin theta 0 to pi. Okay, so now you can substitute the value here. So im square by 4 pi, im square by 4 pi into, so what you will get? You have to substitute the pi value instead of omega 2. So pi minus 0 minus 1 by 2 sin 2 pi minus sin 0. So the value of the sin 2 pi and sin 0 is 0, right? So this whole term will get 0. So now you will get only im square by 4 pi into pi, right? So this pi and pi will get cancelled, and you will get square root of im square by 4. So what is the value of, so square root of im square is nothing but the square and square root will get cancelled, and you will get im, and root 4 means 2, right? So you will get im by 2. So the formula to calculate the IRMS is equal to im by 2, or you can substitute the value. im is equal to, already you know, as per Ohm's law, I is equal to V by R. So Vm by, you are having in half wave rectifier, you are having a 2 resistance. One is the resistance value of the diode, that is a RF, plus RL is the load resistance, right? So you can write IRMS is equal to im by 2, or Vm by 2 into Rf plus RL. How you will get, instead of this Im, you have substitute Vm by Rf plus RL. Okay, clear? So this is how you can calculate the IRMS. So in a numerical problems, if they ask you to find out the IRMS for half wave rectifier, means you can get the values. If you have a Im value, means you can use this. If you have a Vm, Rf or RL, means you can use this formula. Okay, thank you.